Okay, it's sort of fun to evaluate algebraic expressions, but it's even more fun to graph them. So I want to show you how to graph them. So I've got three different algebraic expressions here. Boom, boom, boom. And we know these are algebraic expressions because they have a combination of numbers, operators, and variables. So here, this first expression, it's got a number, there's 4, there's an operator, plus, and a variable, x. Same thing with this expression. We've got numbers, 4 and 1. There's a variable, x, and an operator. It's being added here. So we can graph these to show their value for different values of the expressions for different values of x. So let me show you how to do this. Alright, let's look at this first expression. And what I want to do is I'm going to make a little table for this guy where I record all the different values for x that I want to substitute in for x, and then I'll evaluate the expression and write the value down. So for x you can pick anything you want. Pick some small numbers, that's easier. I'm going to choose 1 and 2. All you really need is 2 different points, so let's just go with that. So if I plug in these values in for x and evaluate the expression, I can then write down what the value is, the result of the evaluation. So put in 1 for x here, so I would get 1 plus 4. So if I were to evaluate that, I would get 5. That does not look like a 5. That looks like a crazy neon squiggle. There we go. 5. So I'll write down 5 for my answer. Let's make that green so you can see that. And by convention, we call the answer the variable y. So we call that column y. So here's the different values that we can plug in for x, and then I'm going to record the result of the evaluation, y, over here. So that's a 5. So let's plug in 2 for x. So then we get 2 plus 4 is 6. So let me show you what to do with those results. So here we are on the coordinate plane, and there's 2 axes. There's the x-axis, with which I can represent the different values for x that I chose, and then the results of the evaluations I can plot on the y-axis. So for example, if I wanted to plot this pair of numbers, I could do, so x is 1, so here's 0, 1 on the x-axis, and then when x is 1, that expression evaluates to 5. So 1, 2, 3, 4, 5. Let's try this one. When x is 2, the value of this expression is 6. So x, I'm going to put the value of x on the x-axis, so 1, 2, and then the result of the evaluation, 6. I'm going to plot the y-axis. So x is 2, and then 1, 2, 3, 4, 5, 6. So I have 2 points. Once I have 2 points, I can draw a line that connects them. And that line is the line that contains all the points for which this expression is true. Alright, let's look at the second expression here, 2x minus 3. And let's make a little chart here. Matching colors. I'm just kind of drawing all over my coordinate plane because that's where there's room. So I hope you're cool with that. So let's pick a couple different x values. I'm going to mix it up. I'm going to choose 0 and 3 just to make it slightly more interesting. So I'm going to plug in each one of these x values into the expression and evaluate it, and then write down what the answer is. So if x is 0, 2 times 0 is 0, then minus 3. So answer here is negative 3. Okay, if I plug in the 3 into x, then I have 2 times 3 minus 3. So 2 times 3 is 6, minus 3 is 3. So I've got 2 points here where I can plot the results of my evaluation of this expression. So when x is 0, then the value of the expression is negative 3. So I'll plot 0 on my x-axis, and then y represents the result. So 1, 2, 3 downward in the negative direction. So that's negative 3. That's 0, negative 3. Okay? The second point is when x is 3, I evaluate the expression and I get an answer of 3. So I'm going to plot this other point at x is 3, and then y, the result will also be 3. 1, 2, 3. So that's a pretty similar line. Let's draw a line that connects these points. Let's say something like roughly like that. Boom. So these lines actually show every possible combination of plugging in x's, anything from 0 to negative 10 to 10,000, and the resulting y. So this line, if I were to say, let's plug in 1, 2, 3, 4, 5, 6 into that expression, I would get an answer of something like 1, 2, 3, 4, 5, 6, 7, 8. A little bit more than 8 would be the result. Alright, let's do this last one, and then this is just going to look like a big mess. It'll be kind of fun. Alright, so 4x plus 1. Let's make a little chart over here. Oops, let me make that the right color, the matching color. And we're going to pick some x's to plug into the expression and see what happens. So I don't know. Let's go back to the old school. 1, 2. Oh, that's a 7. Let's just say 1, 7. I don't even know if that's going to be on the graph, so just in case, let's put a 2. Alright, so we're going to plug in each one of these x values into the expression, and we're going to evaluate it, see what its value is, and see what happens. So if we plug in 1 for x, we get 4 times 1 is 4, plus 1, that's 5. We're calling all of our results of the expressions y. Okay, let's plug in 7. 4 times 7 plus 1. 4 times 7 is 28, plus 1 is 29. Yeah, that's not going to be on the graph. So let's do 2. 2 into this expression. 4 times 2 is 8, plus 1 is 9. Can you even see that? Let's see. So that's 1, 5, and 2, 9. So let's plot those guys. If x is 1, then the result is 1, 2, 3, 4, 5. Ooh, intersects with that other line. Let's see if alright, what about this point? If x is 2, then when we evaluate this expression where x is 2, then we get 9. So we got 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. Oh, that almost fit. Put 9 up there. Let's connect that with the line. So that guy would look something like that.